Hello, everyone. So my name is Amit Sama, and today we will be talking about how practically we can approach to Kaggle competitions. I have been working with Daimler Trucks Innovation Center India, which was formerly known as Mercedes-Benz Research and Development India. I work with them in the capacity of senior data scientist, and mostly we work on natural language processing, computer vision, and we do hardcore research on processing data. Let's jump right into the topic. So today's agenda, we'll understand what a Kaggle is. We'll understand our problem statement, basically the Kaggle competition. We'll go through how a data scientist approaches the Kaggle competition. We'll do some kind of we'll do exploratory data analysis. Once we do the ETL, we'll do the feature selection. Once we are done with the feature selection, we'll build our model. We'll submit our results and we'll refine our process. And at the end of the day, I'll provide you resources from where I have gathered the data and the skills for the data science. So let's discuss what Kaggle is. Basically, Kaggle is a community for data science people. So it's not just limited to the data scientists. Anyone, even if you don't have experience, you can hop onto Kaggle. You can go through there are a lot of materials on Kaggle, like learn, and then there is performance, then there is competitions. You can go through, even the novices can join this community and groom themselves as a data scientist. The best feature of Kaggle, what I personally like, is getting the GPU integrated Jupyter notebooks. Right now, this is, if I believe it is available on Azure ML notebooks, and then Google Colab. After this, the only platform which I recall is Kaggle, and I use it extensively, and it gives me nice growth. Best part about this is definitely we can access a lot of data sets. We can publish our own data sets. Inside Kaggle, you can find almost around, you will find the code and the data you need for data science work, and over 50,000 public data sets. So that's huge. Any kind of problem we can address, we can find our data set related to it and build model around it. We have around 4 lakhs of public notebooks. Just to give you some context, this is enormous. So even if you are going through any kind of issue where you don't know where to begin the analysis, you can just refer to any of the public notebooks, and there are wonderful people on Kaggle which can help you with this. Another great thing about Kaggle is that learning and the practice part. So over here, we can see the learning path. We can see Python, we can see pandas, we can see SQL, we can see time series data. This gives us a very extensive knowledge of each and every subject. So I was saying that even a fresher can join and start learning how to code, how to do the visualization, how to build models. So similarly, you can see over here, we have introduction to programming, which is very, very basic, which gets you on board with Python. And you don't have to have a coding experience whatsoever. It will start with very fundamentals. It's really good. I have personally used it, and my friends have used it. And I can vouch for this course, basically. So the next step is definitely data visualization, where we use Matplotlib, we use PyPlots, and develop the intuition, what data science is all about, what the data you have got. We can visualize it on the plots and see and gain the insights. As soon as we do the data visualization, again, the important part of data science is feature engineering. Which particular feature would we require to improve our model, or even if we are adding a lot of features, what impact it's gonna cause on our AI model. Next, we discuss. We can go into the depth of SQL. Then comes into introduction to deep learning. And boy, this is one of my favorites, because this gives you intuition onto how deep learning actually works. And the best part about this is this actually mimics the human brain, the neurons, the perceptrons, how data scientists have inspired from neural science and have implemented onto mathematical models, which is the foundation of deep learning. So I'm saying that if let's say let's see the computer vision example. So if there was no deep learning, we didn't have a Tesla with autopilot feature. If we didn't have deep learning, we didn't have a Siri or a Google Assistant. So every technology which is latest in terms has been built on this deep learning models. Then comes the data cleaning part. The data cleaning part, almost 80 to 90% of our job is to clean the data, because in real world, you'll never get the CSVs as clean as in the Kaggle competitions. So we understand what part of data cleaning, how to approach this, and what is the most efficient way to get insights from our data. And then definitely what I think one of the critical part of being a data scientist is introduction to AI ethics. So basically what this portrays is whether you have developed a model, but is that model biased towards a particular race? Is this model particularly biased towards ethnicity or gender? We have, as a data scientist, we have immense responsibilities, because you never know how many lakhs of people can use your model, and then there is an inherent bias towards in the data, and you haven't tackled it because you have just been laid back and you haven't gone through this AI ethics. So this comes in very handy when it comes to non-biasing our models, basically on race, creed, caste, religion, and gender. And the most fun part of the Kaggle. So here we can see we have Titanic machine learning data set competition, where we are going to apply our knowledge on that Titanic data set, and then we'll be able to then we'll have another notebook where we'll be able to fine tune our model and see what skills we require for better accuracies. This particular problem is a classification problem. We can see the second competition is based on house prices, which is advanced regression techniques. So the machine learning deals with two major problems. The first is the classification one. The simplest of them would be identifying whether the given image is dog or a cat. So it's categories or classes. And then the second is the continuation problem. So let's assume that there is a house sale of, let's say, 50,000 US dollars to 1 million US dollars. So you cannot put it into the classifications, because then there will be a continuous values, and then there will be fractions and whatnot. So the continuous values always will fall under the regression part. And then if there is a finite categories, that will fall under the categorization problem. Then there is a space Titanic, know what that is. Then there is digital recognition, digital recognizer, where we will be using the computer vision fundamentals, which we will be learning on deep learning. But this is out of scope for now. We will be just focusing on the Titanic machine learning disaster. So let's get started with Kaggle now. So here, and I encourage, if anybody is, I would encourage that they would code side by side, and then they will get the results, because when you hit the results, it's another feeling. So here we can go through the Kaggle. Here we have Kaggle. Here we have the learning part about it. I use this a lot. Then we have the competitions. The best part about this is whenever you acquire any skills, you can directly put them into practice with the help of competitions. So we have right now we are doing we'll be doing the Titanic's data set, and then another part about this is there are another active competitions where once you are confident enough, you can definitely jump onto the practical competitions where you can earn 1 lakh US dollars. That's roughly around 82 lakh rupees. So that's a gold rush if you just hit just one jackpot. let's go to the getting started. Here we'll find our Titanic data set, total teams, here. So here, the first thing, whenever we are approaching any kind of a Kaggle competition, we'll go through the description. So it says, oh, hi, welcome to Kaggle. You are on the right place, indeed. So initially, whenever we want to go through these competitions, let's read through the description. The first challenge of this would be to predict, to create a model that predicts whether passengers survived in the Titanic shipwreck or not. Then the challenge would be, okay, so it just gives us the history about how it was unsinkable RMS Titanic. And then the details, what we're going to use would be name, age, gender, socio-economic class, etc. Basically, how we are going to approach this and the steps given by Kaggle itself is simple. Join the competition, read about the description, accept the competition rules, and gain access to the data set. We won't be using a separate Jupyter notebooks. We'll be using notebooks provided by the Kaggle. So it doesn't have a lot of hassle to begin with. Once we are, and these are the Jupyter notebooks with free GPUs. So yeah, that's a win-win. We'll build our model, we'll make submissions, we'll check our leaderboard, where do we stand and how do we improve the score will be the recursive part. This is just the data about, okay, what data will I use for the competition? There will be a train data, the train CSV, then there will be test CVSV. Train would have around 91 to be exact, the total number of instances. It will also give us the ground truth, whether a person would have been survived or not. In test, we won't be having the ground truth, and that's how we'll be able to evaluate whether our model is working fine or not. So, and in the test CSV, we have around 418 passengers on board, and then we'll be trying to improve this test accuracy, and then we'll be submitting our Kaggle competition. Have the data. Okay, this just gives us how do we submit. So it's just a screen grab of we can click on to submit, and then we can either upload the CSV, which we won't be using because we'll be directly doing it with the help of Kaggle notebooks. So we don't have to go through all this hustle. Now it says about the how the submission file should look like. So it has to be exactly 418 plus the header row. If there are any extra columns, it will throw an error. So we have to be careful. The only two columns has to be passenger ID, sorted in any order, all right, and the survived, the prediction. So basically, we'll predict whether the person has survived or it has not. All right. Yeah, as they are mentioning that this Kaggle notebooks is no setup, customizable Jupyter notebook environment with free of GPU and a huge repository, of course. Let's go to the evaluation. Here, now we have understood from the description that we will be getting the test CSV and the train CSV, and we have understood the format of in which we have to submit for the valid submissions. The goal is to predict whether the person would survive or not. Here, the metric, what the Kaggle is using is accuracy. We can use this accuracy matrix, but right now there have been debate on this, and then we can, for classification, it's better to either use precision or recall or F1 score. Submission file format. Okay, and let me know if I'm going too fast, because every time I just watch anything onto 2x, so I have a habit of probably going too fast. If anybody find it difficult, let me know. I'll just slow it down. All right, submission file format. All right, so here we can say that in our test we have 418 plus the header row, and it will show the error. As we know, this will look like the submission file would look something like this: passenger ID, here we have the passenger ID 892, and it has not survived as per predictions. The tags are beginner, okay, tabular data, binary classification. All right. Yeah, there are in classification, there are multi-class classification, and then there is a binary classification. Right now, what we are addressing is very introductory, which is binary classification. Going forward, we can, based on similar models, we can build multi-class classifications. Okay, so here, what are the competitions? Okay, the best part about Kaggle is it's MOOC. So MOOC stands for Massive Open Online Courses, which help us in understanding without paying anything. So basically, they are free. Another part of this is we can do it into making teams. So let's assume that one of you are good into visualization. Another one is good into feature exploration or feature engineering. Some other guy is good into algorithms. So you, 3 people or 4 people can join together, build a team, and then apply for competitions. What are the notebooks? I assume that everyone would be knowing what a Jupyter Notebook is. Jupyter Notebook is just a IDE where we integrated development environment where we write our Python code, and then it's easier for us to execute it basically. Support. All right. Now the main part, the data. So we can see there are 3 files. Size is okay, minuscule, type CSV. We'll see if there was XLSX or any other type of file, how people could have misled and how could this would end up into an error. Right now, there are 2, the data is given into 2. There is training set, which is train.csv. Then there is test set, which is test.csv. The training set should be built on the machine learning model. As always, whatever the training set we have, we'll use that to build, to train our machine learning model per se. And then have the ground truth. So it already provides us the Y variables where we have the values of zeros and ones, whether a person has survived or not. That's how our model starts predicting, start building a logic around it. This test set definitely would not have the ground truth. It will just have the features, and then we'll have to do the prediction part. We have also included, they have also included gender submission CSV. Okay. And then they are saying that, okay, in right now, whatever the sample they have attached to this, they have predicted the female passengers would survive. Now comes the critical part where we see the data. And here we can see these all are the column names. We have survival, definition is survival. Wow, great. So 0 means no, didn't survive. 1 means yes, it survived. We have P class. P class would be the ticket class. It would be it will be again a numerical class where it says 1 as a first class, 2nd as a second class, and so on. We have sex where it will define the male or a female. They have missed it. All right. Age in numbers. We can have. We'll see. We'll explore. This also would be a critical part when we are trying to build our model. Okay, this is for siblings. SIB special, number of siblings, spouse, aborted on the Titanic. Then we have parts for the number of parents, children's, and aborted on the Titanic. Then we have the ticket number. Then we have the ticket number is usually alphanumeric, and we'll be skipping this particular column because I don't think so it will be helpful for our model building. Then we have fare, where the passenger fare would be declared. This again would be a numerical value, and we'll be able to use this. This will be one of the critical column. Then we have cabin numbers. Probably it will be alphanumeric. Then embarked, where the journey started from. Here you go, right? This is a category C for C, Q, and S for Southampton and all. Variable nodes. All right. Let's explore what the variable nodes are. P class is basically a proxy for socio-economic status. So first would be the upper class, no brainers. Second would be the middle class. Third would be the low class. Age, again, age would be in the decimal format. In computer terms, let's say float. And then we have sibling special. So the data set defines family relationship in this way: siblings, brother, sister, step brother, step sister, spouse as husband, wife, and definitely not. We have Parch. The data defines the family relation in this way. Parch would stand for parents, mother or father. It is self-explanatory. Child, daughter, son, stepdaughter, stepson, and all right. And if they are traveling with nanny, the Parch would be 0 because neither of them. Here we can see our data, gender submission CSV. So this is the sample data which they have attached for us to understand how our submission CSV should look like. So let's go through this. This will be a passenger ID, and this will be whether a person has survived or not. So basically, this will be our target variable. And this could be randomized. It doesn't matter. So even if it's not serialized into the passenger ID, but we have to be careful whether if we are saying 900, then the value of prediction should be the same, right? We have 3 CSVs, total number of strings, integer, decimal, and others. Let's explore train data set. Here it says, okay, there are total 12 columns, but right now we are able to see just 10. So first would be the passenger ID. This will work as a, this doesn't have any significant insights into this because it's just, it serves as an index probably, and that's about it. This is our target variable, which is also called Y variable when we are in terms of machine learning, because X would be the features, Y would be the target. P class, we have gone through this. This is particularly which first class, second class, or the third one. Then there is a name which has around 891 unique values. This defines that each and every individual, every row, we have total 891 rows, and then there are 891 total unique values. Here's a ratio, and it's little skewed. Male 65%, female 35%. We have age over here. This is basically, we are doing exploratory data analysis, but with the help of Kaggle. We can do it on Python also, but this way we can, we don't have to write a code. It's just code free, and we can get the insights, how skewed our data is. So here we can see that we have, it's a little bit right-sided skewed, where we have values of person even till the 80. And then the starting one is 0.4, which initially doesn't make sense. But if you recall that there were infants also. So this one would be, the youngest one would be probably 4 months, 2 days. And then we have siblings, number of siblings. Then we have Parch, parents. Parch stands for parents, child, all right. And then ticket, again, the unique variables. Mostly we won't be using these values because it won't give us, give our model any benefit. Then we have fair, and which is, there are a lot of null values in this, and then it goes up to 512, probably in dollars. The missing data here is the cabin and the embarked, because we are unable to see over here. You can see this into the compact. We'll again be using the data frames, and we'll be visualizing this data as well. All right, we are good to go, I guess. We can just go through the test data, and here definitely you would find little weirdness, because here it's just 10 out of 11 and not 10 out of 12. because obviously we are not using a predictor, the y value, the survived one, which our model is going to predict. All right. So those who are following with us on this Kaggle, you can jump onto with the help of new notebook. As soon as you click on this, the Jupyter notebook would start loading, and this would look something like this. Here it explains that this is a Python 3 environment. Or if we know, we all know that 2 has been discontinued, and many helpful analytics libraries have been pre-installed. And the Docker image of this is given on here, GitHub, Kaggle, Docker, Python. And they are giving us an example of several helpful packages have been loaded, just as NumPy, or linear algebra. Then we have pandas for data processing. Basically, data structure also, it will be giving us a data frame. Then the importing part. So if you want to run any kind of this Jupyter notebooks, we can use Shift Enter. I always use this Shift Enter. I never go for this. I just feel it's redundant, or we can go over here also. Once you run this, you will be able to see this. It will start giving us these 3 values. Now be very careful when you are whenever you are coding the addresses into Jupyter notebook. A lot of time people would give the address just to train.csv or probably their local machine's address. It's not going to work. Here we can see in the input. Yeah, here we can see. We can copy the path from here also. So this will basically be the path. We can use this path or this one. Either way, it's fine. All right. So we'll load our test CSV, which will give. Okay, we'll go through this. So here we'll be using pandas, and in pandas we have a function read CSV to read the CSV. Now, if somebody is new and if they are using, it's going to throw error because file is not recognized as an Excel file. A lot of people do this. I have done it surely. So make sure whatever the file you have, you give the proper extension and read it properly. We run our test, we load our test, we load our train, and then let's do the exploratory data analysis in Python in Jupyter notebooks. So here we can see, all right, we have passenger ID, we have P class, we have name, we have sex, we have age, we have siblings, we have parch, ticket, fare, cab. It gives us, okay, this non-null value counts. So basically we'll say, okay, 418, 418, 418. And here we can see the age, we have a little bit of a missing value. It will also give us the D type, which is nothing but a data type. It's integers, float, and then object, which belongs to it. It can have string, it can have alphanumeric values. So here, dropping the column as this looks a lot. We'll just we'll try to build a simple, very simple model, and then we'll start to go from there. So we can see that name here is an object, and then we don't think that name would be essentially determining whether the person is surviving or not. Again, the siblings also would not matter that much. Parch, all right, ticket, fare, cabin, and embarked. So what we're going to do is we're going to drop this columns. And how do we do this? We use dot drop, and we are dropping the columns. We do it for both test and train, because if we are dropping it in train and we are not dropping it in test, then it messes up our structure. Now once we have dropped, we'll see which all columns we have. So right now we have passenger ID, we have survived, we have P class, we have sex, we have age, and then, all right, this seems to be old, all right, and then we have age. Now, the only non-numerical value is sex, and we have to convert this into the numerical ones. So how do we do this? The manual way to do is we define a column, we do a map, we map for male equals 1 and female equals 0. And once we run this, we are good to go. So then here we can see the column has been converted from object or categorical variable to the binary variable. Now we'll do it for this. Now we'll just check the values. Okay. I can see we have null values also in age. So if there are null values, it messes up with our algorithm, whatever the training model we are using. So right now, just for the sake of saving our time or saving the head, we'll just fill it with 0, presuming they are babies and they have not listed any age. Now, the critical part, where we will select our features. So the first feature would be class. So it would be the first class, second class, or third class, age, and the binary. And then our target is the survived, whether a person has survived or not. So we have features, we have defined features, we have defined target, and we'll just go through how this looks. This is our data. All right. Now we'll import a tree, a decision classifier. We'll just run this. We'll use our classification model as a decision tree classifier. Here, just make sure that you don't mess up. Here we will use train and then the features of it, and train and the target of it, because we are training our model right now. So we will be training our model, and this is a lot faster than probably our own local machine. So Jupyter Notebook helps us a lot. Once we have trained our model, we'll do the prediction part. We'll use the CLF to predict. We'll do it on our test features. This is our predictions, which right now looks very gibberish. It's just an array, but let's make them into a readable format, or whatever the way we have to submit it. So we know that there will be only 2 columns. One would be the passenger ID, and one would be the survived. So we'll just pass that dictionary to create a data frame, and then it would be output. Just look how this looks. So it is similar to what we are expected to submit. Compact, passenger ID, survived. Here we are doing the same, passenger ID, survived. This is nothing but just an index. We'll be ignoring this. Index equals false. We are going to submit it. And now comes a important part. Once we have done this, we will be all right. We don't have to go through uploading our file or doing all those sorts of things. We can just click on to submit. We can just name it into, okay, test 1, then submit. So this is running our notebook right now. If there are any errors into your notebook, it will throw an error and it won't submit the data. It will just take some time. Let's wait it out. By the way, any questions? All right. Right now, we are deciding to drop the columns based first on the categories, whether there is a category or not, and then our general intuition, whether a particular column, let's say the name is another. We are talking about the ethics part also. So name is something which is very private. So we will skip that column also. And then the ticket doesn't have any kind of a identifier when it comes to identifying whether the person would survive or not. If it's not associated with the class, let's say first class, second class, or third class. So that's how we decide to drop the columns. All right, we have the submission is complete. And we have scored 72. So this means our model is 72% accurate. And we had dropped a lot of values over here. Right, let me minimize this. I hope you guys are coding side by side and getting the same results. If you are having any doubt, please ask it into question and answer session. Here, basically, we have dropped, all right, we'll be using Embarked also, I think so, in the next iteration of the notebooks. So right now, our score is 72. Now, we want to improve our score. So what we are going to do? So again, let's launch another notebook and start coding. Or you can use your same notebook and you can just run the CSV. We have splitting it into train CSV, test CSV. Yeah, here this is the example which I was trying to show you. So if you do the read Excel, it will throw an error because the file is .csv. For us, everything opens in Excel, but not in pandas. We have to be careful. How do we read our files? Again, we do a data exploratory analysis over here. The number of columns, we can see 12 numbers over here. We identify which of the columns we would be using. So as I explained, excuse me. So as explained, passenger ID, then we'd be using the survived is definitely our target variable. We'll have to use it. We'll be using P class because it identifies whether the which class has most survival ratio. So first class would no brainer have a highest survival ratio, second class less, and the third class even lesser. Name is nothing but the privacy concern issue, so we'll be dropping that for now. And then we have sex. So this is very important column, especially in Titanic dataset, because whenever the calamity hits, the first thing we try to evacuate is women and children. So women in Titanic dataset also, we have a very skewed ratio of survival from the women and survival from the men. Age also depends because the older people will be given higher preference, and the highest fatalities are between 18 to 30. Then this is okay. We'll be ignoring the siblings and the parch because they don't right now really make any sense. Take it because they are just an alphanumeric random variables. Doesn't make any sense. Fare we will be using because that will determine if the fare is high and the class is high, which will definitely correlate. The survival rate would go high, and vice versa. Cabin also, I think cabin has a lot of missing values, 204 out of 891. So we'll be dropping this column because a lot of missing values doesn't make any sense. And here we have embarked. So this is basically from where did you start your journey? And we can estimate that if a person is starting its journey from either from C, there were some variables. Let me see. Okay. Yeah. Either you are starting from C, Q, or S. It depends whether the survival rate would be higher or lower, depending on where did you start your journey from. So here we are. We have so right now we have identified. Okay, we'll be using P class. We'll be using sex. We will be using age, and we will be using fare and embarked also. All right. So let's select. In here we were dropping. If you can see, we are trying to drop our whichever variables we are not using. In here, we change our method. We just use whichever columns you are using, and then the rest of them automatically are discarded. So we can either code it into that way or this way, doesn't matter. We'll just run this cell. Now, a lot of times newbies make mistake is when we are pre-processing for our data, we do it for both, for the train and for the test data set. A lot of times what I have seen a common mistake is, and even I am guilty of it, is I just do the train part and I miss out on the test part, which really messes up with your algorithm. So here we can identify, okay, This is our training. We have 4, 1, 2, 3, 4, 5. We have total 5 features per se. And then in this, we will need to identify which columns need a pre-processing and which need not. So right now we can see over here, this is a numerical value. This is a categorical value because it is a string. Here again, it's a numerical value. Here it's a fraction, again a numerical value. But here we see that it's again a single character but it's defined as a string. So right now we'll have to process the sex and the embarked, and let's get into it. So initially, when we are trying to do the data pre-processing over here, we used a dictionary. We used a manual method where we said that male equals 0, male equals 1, and female equals 0. Over here, we'll just use the get dummies, and this is way easier. You don't have to pass on to dictionary. You don't have to loop it around. Just run this and you get all the dummies. So here you can see for initially we had a column of sex, and now it is changed to sex female. 0 means it's not present, it's not female. 1 means it is. And over here, sex male equals 1. That means it's a male. For 0, it is not. So it's it just makes sense to have just more columns. Then we had embarked. So embarked had just 3 values, S, C, and Q. So we have relative columns to it. So it will definitely, if 2 are 0, another one would be 1. We do the test. We do the same process for the test. We check our values, whether the values are right or not. And yeah, looks pretty decent. Everything has been converted to numericals. Yeah, I forgot to say one more thing. Whenever we are processing any kind of a data into machine learning algorithms, it has to be numerical. Categorical values won't work. So we have to convert. There are a lot of ways to convert this into convert your categorical values into numerical values. One being defining whether it's nominal, whether it has a continuation, and you can use either one hot encoding, and there are a lot of methods to handle categorical variables. Right now we'll be seeing that, okay, why train. So right now we are defining from our train model, from our data frame train, whether a person has survived or not. This column, we are transferring it to Y train because this is our Y feature, Y target. Let's do another analysis. Let's take our X train and then identify, all right, for age, we have a missing value. Whenever we have any kind of a missing value, we try to fill it or probably keep it as it, replace the values with 0. So initially we did with 0 and we saw the 72% of accuracy. Let's now change our method from putting 0 to the mode of age. So we'll do it for the X train, X test. Now I'll go through this and we can say, all right, so we have just one missing value in fair, but we'll have to do the pre-processing over here also. So again, we are using a mode for the fair, and we have done. Again, here we are using, there we were using tree classifier, probably. Here we were using a decision tree classifier. Here now we are changing our method to random forest classifier. We'll use the sklearn, popular data science library. Our model will be random forest classifier, estimators 251, 250. The depth of our forest would be 7. The random state to keep the results consistent. Here again, the major part where a lot of people make mistake, we are using X train and Y train. Y train is nothing but the X train with the Y features, which is survive or not. All right, we'll do the prediction. And here again, we'll just visualize how our array looks. All right, this doesn't make any sense. So we'll convert this into a data frame where the test data would be the passenger ID and survey would be the predictions which we had predicted. We done this. Let's see how this looks, whether it matches how the submission file has to be there or not. All right. Yeah, looks pretty fine. P capital, passenger ID survived. We have survived number and the predicted value. It is total 418 rows. Let's generate the file. And then the best part about this is just submit it from here. You don't have to do anything else. Simple. So it will just start. It will check for our new running file. This is basically the Kaggle running this entire Jupyter notebook at once and generating the submission CSV. We'll see for the question answers. All right. So basically in Titanic competition, the evaluation of the matrix which Kaggle is using is accuracy, because accuracy is pretty easy when it comes to fine tune it. There are other evaluation metrics also, such as precision, such as recall, and then there is F1 score. So there are different evaluation metrics for the different tasks. All right, we'll just see how our model performs now. All right, and we have a pretty good bump. So initially it was 72, and right now it's 77.9. So you can say 78% accurate. Now, the major difference between our initial, the very generic model which we built was, we didn't do the data pre-processing on the age. We didn't do, we just filled it with zeros, just assuming that missing values were just a baby or something. And then we had a very limited feature. So we just had 3 features. In our this, we used 4 features totally. Okay, let me minimize this. Yeah, so here we used 4 features. The embarked was, so here we can see just by adding a single feature and doing a little bit of feature engineering can help us into a huge accuracy. So 72 to 78, it's around 6% of accuracy. So the more you fine tune, the more you do the data engineering, the more you do the data cleaning part, the better your model would be. All right, we'll do the, yeah, we'll do the question answers later. I'll just present. Yeah, so whatever the code we have written over here, I will be posting it into the GitHub repository. You can just go into github.com and Aminsoma, and you will be able to find out the Titanic. And there I'll be posting this 2 repos. I would encourage you guys to not go into this particular repos. You just develop your own, try to find out other notebooks, and then understand how the feature engineering and the data cleaning works. Basically, what I wanted to convey in this was to pass a value and to generate a model is very simple. So here, this is all about the model ML process which we are doing. So we are just calling out a random forest classifier. We are fitting it and we are predicting it. Just 3-4 lines. That's about it. But main critical part is the data cleaning, the data understanding, the exploratory data analysis, what we do. That makes more sense when it comes to accuracy of model. And definitely we can choose different models for different kinds of problems. the major part. Once you have learned, once you have gone through the learning phase, once you have done a lot of practice on this knowledge-based competitions, then comes this active competitions. So here we are, as we discussed in earlier, so we can get, we can get a good money out of our skills if we are able to successfully crack the competitions. So I would highly encourage you guys to first do the learning part, the practice part, and jump onto this kind of competitions. Because who wouldn't want 82 lakh rupees in their bank account? The resources which I have personally found very useful are this. You can do a screen grab, or you can, this will be uploaded into the YouTube, so you will be able to see all these details. You'll be able to stream it. My personal resources, which I have developed this curriculum for, and my profile, and you can reach me on my this email if you have any questions or any suggestions or anything related to data science. All right, let's go to the questions. How did we want from data viewing to the code part? I'll just show it to you once again. So we were here into the, we just went for the overview. We understood what our task was. Then we went to the data. Then this was the part, and then we went to the code over here. So here, from here, code, we just clicked on over to this new notebook, and this is, you can just change your notebook's name to whatever the project we are working on. It will be like anything you can say, a Kaggle competition, and this will be preloaded. If you want to see whatever the inputs are, because this will change depending on the competitions, which competition you are into, this inputs will change. You want to copy the path, you can copy the path from here, and then this will be your output. So right now we won't be able to see any CSVs because we don't have done any kind of running over here. And once we are done with our model, we'll be able to submit it directly from here. How to find any outliners present in a data. So we can do the Python, we can write a Python code for that. We can use any kind of a matplotlib to identify whether the data is skewed. But you don't want, if you don't want to use any kind of a coding, you want a no-code solution, here it is. So here you will see that there are a lot of here the data is skewed. So 0 is a number of people died, and 1 where the people have survived. And in trained data set, you can see 1 first class, second class, and third class. So third class is skewed. So third class has more values. So you can do some kind of you can reduce. You can do the sampling and make sure that you have any. If you have any kind of imbalance in data set, you can fix it. Thank you. Is the file stored permanently in Kaggle? All right, in Kaggle, the files are permanently saved, so you need not have to worry about it. Pathway to become Kaggle famous. So what are the things need for? Okay. Kaggle Grandmaster. All right. So it is very easy to say, but very difficult to implement. The easiest, the advice I would give is first do the learning part. Second, do the extensive knowledge-based competitions. You will be able to know a lot of different things. Probably pick up a lot of GitHub repos where they have used a very fancy or very niche kind of feature engineering or data cleaning part, and you will be able to understand what Kaggle Grandmasters are doing to become Kaggle Grandmasters. All right, can you show us the nice? This will be you will be able to see it on YouTube. So I don't think so it will be necessary. How does the Kaggle score for us? All right, so Kaggle has its own mechanism when we submit the predictions. It runs in the background. Here we can see first it runs our file, our notebook, whatever the notebook we have written, whatever the code we have written. If there are no errors into it, it will start predicting. Now, if this competition had given already the values for the test data, then anybody would have just cheated onto it, and then they just would have done some kind of a reverse engineering and figured out. How does the Kaggle score? Okay, please share your LinkedIn also, your GitHub. All right, I'll just attach my. Or you can search Amin Sama, AMIN space SAMA from India. All right, I'll just show it to you. Hands on. You can do a screen grab for this. Let's say 20 features. What is advisable to use? Dummy, it will increase. Yeah, this is a good question. So whenever we have a lot of features, let's say 20 features or 25 features, we do PCA on these features. PCA is principal component analysis, where we will reduce all the 20 or let's say 100 features, or let's say 200 features. Whenever we are using on a real data set, a real kind of a data set, it won't be this clear, or it won't be this accurate. So if we are using 200 features, we'll identify which particular features are important. Right now, we saw increasing a feature increases in accuracy. But a lot of times when we have a lot of missing values and we try to fix it by doing data cleaning, it tends to backfire. So more features not necessarily means better accuracy, but the other way around. So we do PCA and we will be able to identify which particular features to be used. All right. Thank you, everyone.